This is Microplastics in the Ocean by Alex Johnson,
Owen McGuire,
Josh Anstutz,
Tanner Bias,
and Barry Haskell.
Microplastics are a very large and contemporary issue right now. Microplastics are very small pieces of plastic and debris that are in the ocean. They come from the use of consumer products such as clothes and plastic containers. Also, some come from industrial waste, which doesn't break down very well. According to Sherry Mason, professor of chemistry and sustainability coordinator at Penn State, she said, first, plastics are made from fossil fuels, so producing them creates greenhouse gases that contribute to the climate crisis. When plastic doesn't biodegrade, that means if it doesn't break down, its basic components they get stuck in the soil and they don't break down very well. This shows that plastics are not good for the ocean because they can really habitats. These microplastics are severely damaging ocean life. They do this in many ways. First, they greatly change the food chains. They do this by killing or damaging the animals and where they live. This causes many animals to either not have as much prey or entire species to be wiped out. Some of the ways to counter this are either picking them, reducing the way they get into the ocean, or creating devices to completely clean them up.
So now you ask why this problem is irrelevant. And the main reason is because of plastic pollution. And plastic pollution is associated with the top threats to our oceans. And it is estimated that by 2050, 33 billion tons of plastics will be in the ocean. So we need to stop it now. Now we will talk about the different solutions to the problem of microplastics in the ocean. The first is using different removal technologies to mitigate the microplastics in the ocean. So there are several technologies that have been investigated and successful, according to Beatrice Malcati, who is a structural engineer. Some of those technologies that were mentioned are absorption, sedimentation, ultrafiltration, magnetic removal, and many more. There also is a 3-layer chamber which can be incorporated into cargo ships, and when used successfully, it can remove up to 204 tons of microplastics a day globally. And some of the solutions and limitations. The one is that it's very expensive to use, and they also have not been tested on large scales like the ocean. Many of them have also not been mass produced yet, so it would be hard for them to be used to their maximum potential now.
Our second solution is using wastewater and drinking water treatment systems. Water treatment systems tend to use two-step filtration processes to clean out the water. And according to the World Health Organization, these are around 90% effective right now at clearing out microplastics. And with the addition of nanofilters, these could become 99% effective for drinking water and 97% effective for wastewater. But the negatives are nanofilters are very difficult to install on a large scale, but they're easy to install on a home scale. And on average, to just install a basic treatment plant is around $4 million, and a large-scale treatment plant is around $10 million. And the countries that suffer from microplastic issues most tend not to have the money, industry, or supplies to build these types of plants. So right now, it is not very sustainable for them to build these types of plants. And the main problem is treatment plants only can prevent microplastics from getting out into the water, but they cannot currently help solve the problem with microplastics in the ocean right now. But in the future, if we were to start using maybe seawater, it would help prevent those microplastics from getting into our drinking supplies.
Our third solution is using alternative substitutes for toxic resources that pollute waters with microplastics. This includes biodegradable fibers such as cotton, silk, bamboo, wool, linen, hemp, and an additional multitude of others that, if used, could drastically decrease plastic concentration in the ocean. These materials would take over the extensive waste extruded from the fashion industry. Aside from fashion, other industries using abundant plastic can swap for others. A material that can swap for others, such as rubber, a material that comes from air and therefore would pose little harm towards it. It is better than plastic as it biodegrades much quicker than plastic and also doesn't protrude toxic chemicals once it does. A final alternative is paint. Using natural paint would be one of the largest sustainable changes, as almost every building in the world is coated with the toxic cat. They are made with a limited number of ingredients and are biodegradable. This solution of why eco-friendly alternatives would be difficult to achieve due to the overuse of toxic resources in society. It would take decades to make significant transformation, and the process of doing so would be laborious and costly.
We found that the best solution would be to use material alternatives. This is because there are many sustainable options, especially for the clothing. There's lots of silk, wool, and like hemp, and it's very eco-friendly. And if it gets in the ocean, it won't poison it like plastic does. And also, organic paint is just as effective as the one that's like very popular now and used everywhere. And even though this is the best option, there's still limitations to it. It's because there's going to be a big change, and it's also very popular in a lot of companies, and like water bottles and especially clothing. And another reason this is the best option is because the other options, they're either very expensive, like water treatment systems, or they haven't been tested enough on a large scale.